go over those problems. Then I'm going to give you like 4 or 5 more minutes to work on that worksheet after we go over the homework. Questions, you have to tell me the page number, like 181, whatever. It's on page 181, 189, right? And a couple OGT questions. You have to tell me the page number and the problem. No questions? Just like
182,
number 32 on 182?
Yeah.
182, number 32. Make sure you follow along here. I will say this, I'll do this problem, and when I decide which problems are going to be the quiz problems off that worksheet, I won't count either of the 2 graphing problems on that worksheet as one of the quiz problems. Alright? But you got to be following along when I do this problem to make sure you understand them. 32. You want me to turn it back on?
No, I thought she said she likes the white. I said
Oh, the white. I thought you said something about that. 182. Alright, they tell us that point A is 5, 4. Please remember, if I got to point 5, 4, this killed me on the exam. If I got to point 5, 4, what does that tell me to do?
Go over 5 and up 4.
To the right 5 and up 4. A lot of you doing it backwards. You got to make sure X coordinate tells you to move left or right. Y coordinate tells you to move up or down. So I go over 5, up 4. I think they said that was, that's 5, 4. That was point A. That should be a 5. That's a 5, 4. That was point A. Next point they tell us was B was 3, -1. 3, -1. That's point B. And then they tell us C was what, like 7, -1? Point C, 7, -1. They want us to find the length of each side and then give the triangle a name. What can we use to find the length of a side when you're on a graph? We've been doing this all year long. Say it louder. Distance formula. Remember the distance formula looks like this?
Yeah.
Subtract the x's, squared.
And add them together.
Subtract the y's, squared. My pen for some reason doesn't want to work over here. That's a squared there.
Okay, it was a circle.
So first, what's the easiest side to find in this triangle?
A and C, so
BC is. Why is BC the easiest?
you just gotta count like
Because
the
it doesn't have a
over.
slope.
What's special about segment BC?
It doesn't have a slope.
It's horizontal.
It's horizontal. All of them are straight, Joel. Remember, all lines and segments are straight, right?
Come on, son.
It's horizontal. When it's horizontal or it's vertical, then we can just count. The -1s are the same. How far is it if you go from 3 to 4? 4. So that one, that length of that side, side BC, 4 units long. That one's pretty easy. If I gave you this problem on a test, there's going to be 4 answers. That's one of the answers, so you got 1 out of the 4 just by counting. All right? So don't just skip over it. Pick another side. AB. To find AB, we have to use what? Distance formula. What's the x coordinates for A and B?
5, 7. 5 minus 7.
A and B.
5 minus 3.
5 minus 3 squared. What's the y coordinates for A and B?
4 minus 1.
4 minus,
1. 4 plus 1.
-1, right? And that ends up being plus there. That makes sense?
Yep.
What is 5 minus 3? I'm gonna try to do a couple of these steps all as one. That's 2, 2 squared.
4.
Jordan, that make any sense? 4 plus 1,
5.
5 squared.
5.
What's 4 plus 25? 29. Now, depending on what you're doing, is 29 a perfect square number?
No.
If we're trying to find the perimeter of this triangle or something, then maybe we want to grab our calculator and change that into a decimal form. They didn't tell us to do all that. We didn't have to find the perimeter. I would not mark it wrong if you just came over here and said that segment AB was the square root of 29. All right? Somebody's got a calculator. Tell me what that is as a decimal. 5.4. Either one of those answers would be fine. So this side right here is 5.4. Yeah, I'm not sure what's going on today. Try this and see if it.
Oh, you don't
That ain't
have
gonna work.
now.
Yes. 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 Sure.
I just hit it right in the center.
Yeah, but I shouldn't have to. Something's not right. Oh, I just looked at that. Go back. See, that's worrying me. It's not. What's the other side that we still have to find? So segment AC. Come over here, do the same thing. Use the distance formula. What's the x coordinates for A and C? 5 and, what is 5 minus 7? -2, -2 squared. Chelsea, you don't know what -2 squared is? Positive 4, right? Plus, what's the y coordinates? 4 and -1, so 4 minus a -1, what's going to happen there again? 5, 5 squared, 25. That didn't work, all that stuff I did. What's that give you? Square root of 29, which is 5.4. Approximately 5.4. Are we finished?
No, you're gonna name it.
All right, they want you to name it also. Tell you what. What kind of triangle is this? So it's an isosceles triangle. What is going on? Bet my battery's about dead or something. Next question.
Yeah, week 7 and the 5.
Week 7, number 5. So up in the front on the OGT, week 7, number 5. Oh. What's these arrows tell us on these lines? Those are parallel. Those are parallel. Now, I'm not going to write down all the stuff. They told us angle 1 was 6x plus 45. That's this angle right here. And they told us that angle 5 was 3 times y minus 10. Angle 5 was right here. So 3 times y minus 10. Before I go any farther, what can you tell me about those two angles? They're supplementary. They got to add up to 180. Then they tell us that angle 14 is 8x plus 5. That's way down here. 8x plus 5. Do I even need this line right here? No, as a matter of fact, you want to get rid of that line. Remember, we said when we were dealing with these parallel lines and the transversal, how many lines you want in the picture? 3. 2 parallel and the 1 transversal, right? So you don't even want that other line in there, so that you can tell the special pairs of angles. We already know that these two add up to 180, so 6x plus 45 plus 3 times y minus 10 equals 180. What's wrong with that? It's got 2 variables in it. Can you solve that? No. All right, it's got too many variables in it. What can you tell me about angle 14 down here, this angle?
It's alternate exterior to 6x.
Those two are alternate exterior angles. What do you know about alternate exterior angles? So 6x plus 45 should equal 8x plus 5. Did it work here?
Yeah.
Is that something you can solve? Yeah. So we can solve this. Once we find x, what can we do? Plug it in for x up here, then will we be able to find y? Yeah. Subtract 6x on both sides. I'm going to go through this sort of quick. Make sure you're ready with the next question. 45 equals 2x plus 5. Subtract 5. 2x equals 40. What's x equal? That's part of our answer. If this was on an OGT test, it was said it was worth 2 points. Said it was worth 2 points. They wanted you to show your work and give the answers. Right now you'd have 1 point. You still got to find y. What is 6 times 20?
120.
So let's get rid of that and put 120 in there. We can get rid of the parentheses. So distribute, got 120 plus 45 equals,
3y minus 30.
You mean plus?
oh, plus, I put equals in it. Plus 3y minus 30 equals 180.
We'll pretend that's 180. There.
Perfect.
Yeah.
Collect like terms, what's 120 plus 45? 165 minus 30. 135 plus 3y equals 180. Subtract 135 on both sides. Somebody help me out. What's 180 minus 135? What is it? 45. Divide by 3. What's y equal? 15. Again, 2-point question. Show your work. Found both x and y. Can you just forget all that stuff that we learned about parallel lines and all that?
No.
No, you're still going to need it for the whole year.
Alright.
Next question.
Yeah.
Say it again.
26 and 81.
26 on 181. Only one or two more questions after this, so if there's one like something on the worksheet, like this one is, you might want to be finding it. 26 on page 181. They tell us triangle GHJ is isosceles. If it's isosceles, what's the first thing I need to do?
Make two sides.
Sean, what's the first thing I need to do?
Make two sides the
Before that,
same.
draw the triangle. Does it matter what the triangle looks like? No, it makes absolutely no difference unless it's going to confuse you.
You can might just want to use markers.
About ready to.
Yeah, it seems like a better idea this time.
I don't understand why it works so many times than others. They tell us two of the sides are congruent. Well, we don't know which sides they are. They said the triangle is GHJ. So we'll label that. HG is congruent to JG, so we know those two sides are the congruent sides. Then you got to go through and label everything else. GH is X plus 7. GJ is 3X minus 5. And then X minus 1 is this other side. Is that right?
Yeah.
What equation can I set up from that?
X plus 7 equals 3x minus 5.
Now, watch carefully, please. Because I guarantee, out of this class, as big as this class is, there'll be about 8 of you set up this equation. What's wrong with that?
So the sides don't equal 180.
Sides of a triangle do not add up to equal 180. What in a triangle does add up to equal 180? The angles. Please make sure, very common mistake. I wouldn't even be writing it up here if it wasn't something I've seen done many, many times. 3 sides, do they have to add up to be anything special? No. The 3 angles always have to add up to be 180, but the sides don't have to add up to be anything special. Subtract x on both sides, you end up with 7 equals 2x minus 5. Add 5 to both sides. 12 equals 2x. What's x equal then?
6.
Is that our answer?
No. Now plug it into the other one, so. Next one's
It's part of our answer, isn't it?
Plug in all the sides.
It said find x and find the 3 sides, so we got to plug in. So how long is segment HG?
13.
13, good. How long is segment GJ?
13.
13, they had to be the same, didn't they?
That's just special.
And how long is segment HJ?
5.
I heard 12, I heard 5.
5.
5.
Well, I'm pretty sure 6 minus 1 is 5.
6 minus 1 is
5.
5.
How do you get 12?
That's what I would have known.
How did, I was going to say, how did they get 12? Took the 13 from here and stuck it in there.
Man,
So make sure, take your time and make sure you don't make careless mistakes. Next question. No others? 189, number 14.
5. I'm taking an effort just to read something off the paper.
189, number 14. All right, I'm not drawing that whole picture. It looks something like this. They tell us that this is a right angle. This angle's 27 degrees. And they want us to find this missing angle right here. How can we do that?
90 plus 27, and subtract from 180.
717. Subtract that from 180. 7, 3. So what's that angle?
63.
63 degrees.
Next.
Three angles of a triangle must add up to be 180. You know, you could have been writing all this down. Intelligence at work. Come on now. Other questions? No more?
Number 12.
Number 12 on 189? Number 12 on 189. I'm not drawing the ice cream cone. Got that right there. What's these tell us about those two angles? They're the same, they're congruent. What's that say, 39 degrees? How can we find these two angles in?
180 minus 39.
180 minus 39, that gives us 1, borrow. Is that 141, is that right? All right. Each one of these angles isn't 141. Each one is half of that, so you divide it by 2. What's 141 divided by 2? 70.5. I think there was a couple of problems on the worksheet that looked like that, wasn't it?
We get it.
That one's the same thing. Still won't work. Oh well.
Do you number 26? We just did that. We just did that on 189.
Problem 26, last one. Watch carefully on this one. This is more like the problems I would put on the test. Oh, and this is probably the kind of problem that is going to count as part of your quiz on that worksheet. 36, 69, 47.
What were we on?
Oh, I'm doing the wrong one, aren't I?
Yeah.
Tag on it. Look at the wrong picture.
So this isn't going to be the type of question we were just talking about?
Yeah, it's the same thing.
Oh, okay.
Doesn't want to work today.
I get all of them. Is that all the numbers they gave us? All right, when I'm doing a problem like this one, don't go through, and this is where you guys are having trouble on that worksheet. Don't go through and just try to find the angles that they numbered for you, and especially starting with number 1, because they may put number 1 in the hardest spot to find an angle, and then you're sitting there looking at it, and you don't get it, and you get lost, and then you give up on it. So notice I didn't even number any of the other angles, because we're just going to find every possible angle that we can. All right? Anybody see an easy angle that we could find right off the bat? Don't tell me numbers, because I don't have them up here.
133 and 24.
Watch, I'm going to start pointing at angles. Tell me when to stop. That one?
Yeah, no.
Yeah.
All right. How could you find that angle?
33 and 24. Add together and calculate.
3 angles of a triangle got to add up to 180, add up to 180. That's what, 57? What's 180 minus 57?
123.
123.
123. So that's that angle right there. What's this angle up top then? Now, again, did they ask us to find all these angles? Malachi, I was talking with you about this, right? If you know it, put it in there. Might help you somewhere.
Yeah, cause,
How about this angle?
that's supplementary 150.
57.
Yeah.
How about this angle? 57. Now where?
Now you can get the other two.
This over here? 95 plus 57. What's that give us?
152.
Subtract that from 180. 28. So that's that angle. Well, we got one more angle to find. How are we going to find it? Got a triangle right here, right? Does everybody see that triangle? If my pen would ever draw it.
Yeah.
That's 166. Subtract that from 180. 14. Everybody agree with that? Did we find every angle in that picture? Yeah. Now could we go back and answer all the questions that they asked us? And that's what you should do. Don't start trying to answer number 26, 27, 28, because they're going to try to mess you up. So go through and find everything that you know, then worry about going back. All right, start working on the worksheet. You got about 4 minutes from this point. We'll get it done. Okay. You should be able to. Ask me later on in the week, and I'll try to make sure I get it to you, just in case. Now, these are the 3 problems that are on the quiz.
All right, I got this.
The first one. How do I find these 2 missing angles?
146 from 180.
Subtract 146 from 180. What's that give us? 34.
And then you divide by, which is 7.
Divide that by 2, 17. Yes. Yes. Sure. So 17 degrees each. How do I find angle 2 in this picture?
180 plus 140. Or
No,
185
no,
plus
no. You
140.
gotta get 85 and 40 and put them together, then subtract that from 180.
That's 125.
Alright, yeah, and then,
Subtract that from 180.
and then you get,
What's that?
55.
55. If that angle right there is 55, what's angle 2? 55 also.
That's freaking blue.
How about angle 4? What's the easiest way to find angle 4? I'm going to start handing out detentions if you're talking.
180 minus
It's supplementary to 105.
Those 2 are supplementary. What's angle 4 then?
75.
75. All right, these are your notes for today.
Yeah.
Go ahead and start copying them down. Going to prove triangles are congruent. Now, actually, this year I'm skipping a section.
What's that?
So the section that we're going to skip over actually has you go through and prove, or 2 triangles are congruent the long way. I'm just skipping over that, and we're going right to the shortcuts. How many parts does a triangle have? 6. What are they? 3 sides and 3 angles. All right? So the long way to prove 2 triangles are congruent is to prove all the parts that match up in one triangle are congruent to all the parts that match up in another triangle.
Like a column for
Well, and then we're going to do 2 column proofs. So as soon as you see prove, that's going to tell you that you're going to do some 2 column proofs on these 2 column proofs. Hopefully they won't be as difficult as the first ones, because The rules that we're going to look at, the theorems and the postulates that we're going to look at, actually give you like a blueprint to how to prove the triangles are congruent. Right? It sort of gives you steps. Hey, I need this, then I need this, then I need this. So you just look for those things. So we're going to prove triangles are congruent. Again, that's a lot of two-column proofs for the rest of this chapter. We're going to use those congruent triangles to solve problems. Use a lot of triangles. Again, dealing with triangles. Triangle is a shape that you use a whole bunch because there's so many different rules about a triangle. All right? So if I tell you this triangle is congruent to this triangle, well, then they got to match up perfectly. And that's the only shape that really works out that way. All right? We don't usually try to prove some octagon is congruent to some other octagon. It's mostly with triangles because we use them so much in building and different things. Go ahead. Malachi, you're right. All right. Write this down, definition of congruent triangles. Two triangles are congruent if and only if their corresponding parts are congruent. So what this is saying in this picture, these two triangles are congruent if and only if all the parts that correspond are congruent. When we were dealing with parallel lines, where were the corresponding angles? What did you have to do to figure out which angles were the corresponding angles? What did you do with the two lines?
Push them together.
Smash them together. Right? Sort of the same idea here when you're dealing with triangles. Try to match them up, try to get them to lay together, one over top of the other. What would I have to do to this triangle to get it to lay over top of that triangle?
Move it.
How would you move it?
To the right.
What did we do earlier this year? We did transformations. What kind would that be? A translation or a slide? I'm actually going to write down slide because it's shorter.
Okay.
Slide. Now, not all of them will just slide together. What were the other transformations that we used to match stuff up? A flip. That's one.
Dilation.
Now, instead of rotation, let's not say rotation, that's too long for me to write. A turn. Now, dilation. Why not a dilation?
Because it makes it bigger.
Makes it bigger or smaller. If it's bigger or smaller, are the two triangles going to be congruent to each other? No.
Shh. One's bigger than the other. You're making it small.
You told me you could be quiet there.
I'm being quiet.
No, you're not. Shh. You're going to move back next time I look over there. So in this, angle A in this triangle, if we matched it up with this one, what letter or what angle would it match up to in the other one?
Yeah.
F. Angle B would match up to D. Angle C would match up to E. Segment AB would have to match up to what in the other triangle? FD. That's the way they're going to match up. You're going to have to match them up. All right? Now, we don't know that all those parts are congruent yet. That's what we're going to have to go through and prove or show. All right, write this down. The way the congruency statement is written is important. I'm going to tell you what a congruency statement is. All right, draw a couple of triangles here with it, because we're going to use those. Somebody read that to me. Segment AB is congruent to segment QR. That's a congruency statement. Now the congruency statement that we're talking about this time are for triangles. Somebody give me 3 letters, name this first triangle. How about the second one? Now when you're going to try to name these congruent, what you're going to have to know is which parts are congruent to each other so you can match them up. When you name the first triangle, this is your congruency statement. What I'm getting ready to write right here is your congruency statement. When you name the first triangle, it doesn't matter how you name it. All right? So if I mark Lauren's first triangle wrong when she names it, you'll know it's just because I was upset with Lauren for whatever reason at that point. Because there's no way you can get the first one wrong. All right? So name this first triangle for me. Now what does matter is how you name the second triangle. This sort of common sense. You got to keep it in the same order. All right? What does A match up to in this other triangle? What does B match up to? And then what does C match up to? So you have to name it that way. Name the first triangle for me a different way than what we had there. CBA, I heard. How would the second triangle have to be named then? YZA? YZ what? YZX? Does everybody agree with that?
Yeah.
Is that right?
Yes.
All right. Now, when you're naming these, there's all kinds of different ways you could name this first triangle. So I got to know, when I look at your answer, I got to know every possible way. All right? And then I look and see if you matched it up correctly. But I got to know every possible way that you name the 2 triangles. All right, go ahead. Write this down. You really don't have to skip a whole lot of space in between them. Maybe a line or so. The main thing we're going to write on this we've covered these properties over and over and over again all year long. Crystalline, you with me? Start of the year we talked about these 3 properties all worked in algebra. Then we talked about these 3 properties all worked for segments. Then we talked about these 3 properties all worked for angles. Now today we're going to say these 3 properties all work for triangles. So that's what I want you to write over here. They all work for triangles. So all 3 of these properties work for triangles. The reflexive property. We don't use this for triangles so much. If we were going to use it for triangles, it'd say something like triangle PQR has to be congruent to triangle what? Anybody remember what's the reflexive property say?
Inverse back and forth.
That's this one.
It's the same thing.
The same thing, congruent to itself. So what would this have to say?
PQR.
PQR. Well, we don't use that a whole lot. We don't, want to say this triangle's equal to itself. It just doesn't help a whole lot. But what you probably want to write down here for sure is the reflexive property is anything equals itself, just to make sure you remember that. Now, this will be very, very important when you're proving two triangles are congruent, not because you're going to say this triangle equals itself, but because if I draw a picture like this, how many triangles are in that picture? Three. All right, there's three triangles. In those three triangles, if I split off the two smaller triangles, it looks like that they may be what to each other? Congruent. Looks like they might be equal to each other, right? Well, what do I notice about this side in this triangle and this side in this triangle? Why are they congruent? It's the same thing. It's that same side in both triangles. Reflexive property. This side equals itself because it just happens to be in both triangles. See how smart you guys actually are. If I draw how many triangles in that picture?
Four.
There's four. All right? There's four. Looks like these two little ones down here, maybe they're congruent if I could draw a little better, right? Does everybody see the other two triangles, the yellow one and the red one? Do they share anything? What do they share? Does everybody see that angle right there? If I split those two triangles off, if we call this angle A is going to be in both triangles, isn't it? Is it the exact same angle A in both triangles? Yeah. Now you got to be careful because if I split off these triangles, there might be some B right there. Is angle B in this triangle over here going to be the same as angle B in this little triangle? No, two different ones. But here, they actually share that exact same angle. All right? This is more important. We'll use this a whole bunch. That's one of the easy things. If you see that they share a side, you can say, hey, they share that side because of the reflexive property. Should be one of the easy things to pick out. Symmetric property. Anybody remember what symmetric property say? If what? A equals B, then B equals A. It just splits it around or turns it around. All right? So if we were dealing with triangles, this would just say the first triangle equals the second triangle. Then we know the second triangle also equals the first triangle. Transitive property. What did the transitive property say? A equals B and B equals C, then A has to equal C. So this would say if the first triangle equals the second triangle and the second triangle equals the third triangle, then what do you know? First triangle has to equal the third triangle. Good. All right, we don't use these two a whole lot this chapter. Reflexive property is the one that we're going to use the most, and it's not going to be to deal with triangles. It's going to be more to deal with saying, hey, these two sides are the same because they're the exact same thing. Or these two angles are the same. All right, what I want you to write down on this. Just write this bottom part right here. Skip some space in between each one of these. You know what, I've been writing with this pen that whole time, and that thing hasn't disappeared. Maybe changing that battery. I don't know why the battery would have anything. I've been arguing with Mr. Poole all year long why that thing disappears now, and I can't pause it and stuff. He said it was something that's stupid I was doing. Instead of proving all 6 parts of one triangle are congruent to all 6 parts of another triangle, then being able to say that they're congruent, that's too much. Alright? So these are shortcuts. Somebody came up with a long time ago, some math person said, you know what, we don't have to prove all 6 parts, because if these certain parts are congruent to these certain parts, then the 2 triangles are always going to be congruent to each other.
Right.
Anybody have a guess as to what this SSS stands for?
Nope.
Side. Super secret.
Side, side,
Side.
Something
All right? It's funny, Jacob, but you might want to get back on track. So in other words, if you go through and you show me that these 2 sides are congruent, you show me that these 2 sides are congruent, and then you show me that these 2 segments or sides are congruent,
Then it's all congruent.
what can we say about the 2 triangles then? They're congruent to each other. This is what I was talking about with the 2-column proof. This is sort of like your blueprint. This is sort of like your blueprint. Here you're going to prove a pair of sides, then you're going to prove another pair of sides, then you're going to prove another pair of sides. Then once you have that, what can you say about the 2 triangles? They're congruent. So you sort of have a blueprint, an outline of what you need to go down through and prove. All right? Now the bad thing is that the only outline? No, there's 4 different outlines. What's this next one?
side, angle,
Side, angle, side. Now with this one, I draw these 2 sides are congruent, those 2 sides are congruent. The angle here has to be a special angle.
Right angle.
360.
It's got to be what's called the included angle. Anybody have a guess as to what included angle is?
One where the 2 lines meet.
The one where the 2 sides that you know are congruent meet. All right? So in this picture, where would the angles be?
Right in the bottom corner, on the
Bottom
left,
left corner.
bottom left corner.
Yeah.
So it'd have to be this angle is congruent to
Yeah.
that angle.
All right.
All right? It's got to be the included angle. It's got to be the angle in between the 2 sides that you're showing are congruent.
Why though?
Otherwise, it doesn't work.
All right. Yeah.
All right? So in other words, if you had something different than what this looks like, you wouldn't be able to say the 2 triangles are congruent to each other. All right? So we could have 2 triangles that look like this, Preston. And maybe we knew that this angle was congruent to that angle. This side was congruent to that side. This side was congruent to that side. Those 2 triangles do not have to be congruent. It just physically could be matched up wrong. Okay? What's this next one mean? Angle, side, angle. What do you think has to be true about that side right there?
It has to go in between 2 angles.
Got to be between the 2 angles. Got to be the included side. Draw the picture out here if you wanted. You got angle, angle, another angle here, angle there. It's got to be the side that falls between those 2. All right, between the 2 angles. What do you think this last one stands for? This is sort of the oddball of the bunch.
Angle, angle, side.
Angle, angle, side. Now, the reason it's the oddball This one is sort of the offspring of angle side angle. All right? So it's sort of like angle side angle had a kid, and that's it. Okay? Usually in most geometry books, these three are postulates, and this one is a theorem because it comes from that other one. In this one, I don't think it's that way. I think they're all theorems or something. I don't know. I can't remember.
I think they're all postulates.
Are they all postulates? So this one's a postulate also?
I think so.
So the reason, if I drew two triangles up here, and Preston was, or just let's draw them anywhere. We don't need this anymore, do we?
I don't think so.
So erase all this. If I draw two triangles here, and if we knew this angle was congruent to this angle was congruent to this angle, but then we knew that these two sides were congruent, that doesn't fit angle side angle because it's not the side that's between the two angles. But we had a theorem the other day that said if these two angles are congruent to these two angles, what can you tell me about that third pair of angles?
It's congruent.
They have to be the same. They have to be congruent. So what they've done with angle side is instead of making you put in that extra step to prove that these two angles are congruent to each other, they've said, hey, it's going to work out that way every time, so let's just make another postulate or another theorem. Does that make any sense?
Yeah.
All right, which ones aren't up here? Side angle. That doesn't work. All right? Make sure you don't try to use that one or the reverse of that one. Right? Don't use it. You'll know that that's the Jordan theorem, and I'm going to write on your paper, Jordan isn't intelligent enough to have his own theorem. This doesn't work. So that one doesn't work. What else doesn't work? Angle doesn't work. So make sure you don't try to use those two, because they don't work to prove two triangles are congruent. All right? Angle actually proves that two triangles are similar to each other. And we're going to talk about that later on in the year. How would you prove these two, or what would you say about these two? What of those could you use? Side. And we're not going to go through all that. I was going to draw up a bunch of stuff there, but I'm just going to give you the assignment. I don't know why that went way up there. All right, the assignment's on page 204. It's like 10 problems, but quite a few of them, I can't remember how many, are 2-column proofs. Got to try the 2-column proofs. When you're doing the 2-column proofs, every time for the rest of this chapter, you've got to do this. You write down the problem number, maybe it's number 5, I don't know. You write down the problem, write given, whatever it says, prove, whatever it says, and then you draw the picture out here, whatever the pictures are. Try 2 triangles somewhere in the picture. All right? So draw, write the problem, draw the pictures. The reason I do this, you've got to be able to come out here and label stuff so you can work these problems through. Otherwise, you'll be completely lost. These should be easier 2-column proofs than the ones we did earlier this year.
Hopefully.
Look, now the thing, I shouldn't open up my mouth, but now the thing disappeared.